Sorry.
Hello, all.
So please introduce yourself, and then we will stream your talk, and then questions and answers, as usual.
That sounds great. I'm excited to be here. Welcome to Accento 2021. This is a talk that is all live coding. It is so much fun. We're going to take a look at building tests in JavaScript. And if you've never tested in JavaScript before, I think you'll have a lot of fun with this. I'm Rob Richardson. I'm a web developer and developer evangelist for Cyril. And so this will be really fun. Come join us. Hi, welcome to Accento. I'm Rob Richardson. We're going to talk about JavaScript tests in Node, the browser, and CI. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. But in this talk, there are no slides. The code that we'll build is up on GitHub right now. You can grab this and you'll see the done folder and the start folder. We'll start with the folder in the code in the start folder, and we'll finish at the done folder. You can fork this repository and do similar experiments yourself. And once you get done, compare your solution to mine and tell me what I got wrong. You can grab this repository from robrich.org, click on Presentations, and here's JavaScript tests in Node, the browser, and CI. The code is online right now. While you're here at robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Cyril developer advocate. If you want to talk database security, I would love to bend your ear. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp near you, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I've worked as a core contributor on Gulp in version 2 and version 3. And I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig in. I've got the code cloned here on my local machine and opened up inside of VS Code. We're in the start folder. And our first task is time to first it. So let's say we've got it should pass, and we'll give it a function. Assert true is false. And so we need to import assert from assert. And time to first it, npm run test. We've got our tests failing. Oh, let's get into the one directory, npm test. And we have successfully created a test. Perfect. Now, here in our test, this is actually the description. Here's our condition. In this case, we're validating that true is true. So anything that is truthy here will pass, and anything that is falsy will throw an exception. Now, that is a great way to get started. We also tucked here in package.json, we installed chai and mocha, and when we run tests, we run mocha. So here in our test, when we say mocha or npm test, it will run mocha, and that will kick off our tests. Mocha will automatically discover all of our tests and run each one. Okay, so I've got this library here, and I would like to write a test around it. This is an add library, and I've intentionally made this library simple from an implementation point of view so that we can start to discover how to build interesting tests. Okay, so let's create a new file, test add.js. And here I'm going to import add from /add. And I'll also import chai. Import chai from chai. And I'll use the expect mechanism. So const expect equals chai.expect. There we go. Now it should add 2 plus 3. And I can create a function here and describe how that works. I'm going to wrap it in a describe block so that I can describe how this works. And this will be the add function. Now, I'll create some content there. Now, it should add 2 plus 3. Okay, so I want to do an add, const result equals add, and I'll add x and y. And so let's create const x equals 2, const y equals 3, and then we'll validate expect result to equal expected. Okay, so let's create an expected, const expected equals 5. What we've done is we've created this arrange, act, and assert pattern. And we'll use this in our test to be able to set up the expectations, do the task, and then finally resolve the result. So let's run npm test again, npm test, and now we get the content not only of our hello world, but also of our add test, and that passes. Okay, so JavaScript is weird. We can add strings just as easily as we can add numbers. So let's add A and B. So here is A, and here is B, and we expect this to be AB, and npm test, we can see that we now have 2 passing tests. That's cool. Okay, now let's build a subtract test. I'm going to create a new file, test subtract.js, and of course, as any good developer, let's go copy and paste all of the code. And we can't subtract strings, so let's delete this. And let's should subtract 2 and 3. Let's subtract all of the things. Subtract 2 from 3. So x will be 3 and y will be 2. And we expect it to be 1. Subtract. Okay. npm run test. And ooh, CB is not a function. Well, let's go look at the code that we're trying to test. It looks like in this case, the code is actually asynchronous. Okay, so we're using callbacks in this case. Let's see how we can test asynchronous code. So here in our act, instead of doing it this way, we'll do it this way. Error and result. And we've got this. Now we can expect result to be as we expect. And now, how do we know when the test is done? Oh, let's actually also validate that our error is null. We might need to do some weird things if it's null or undefined, but in this case, it's null. How do we know when our test is done? Well, we can pass in a done function here, and once we're done, we can call done. Therefore, when we run our tests, npm test, then we can validate all of the tasks, and we know when the asynchrony is complete. Perfect. So we're able to write an asynchronous test with callbacks. Very nice. Let's test multiply. Test multiply.js. Now in this case, multiply uses promises. So let's create a promise-based test. Let's change subtract to multiply. And now let's multiply 2 and 3. So 3 and 2, we expect this to be 6. Now I'm not using 2 and 2 because then I wouldn't know if I was adding or multiplying. Now in this case, it's going to return a promise. So we can say dot then and pass in our results. And now we've got a test here. Let's npm test and validate that multiply works as expected. Ooh, it looks like we didn't call our done function correctly. Let's come back into multiply, and that returns a new promise. It will resolve that promise. So it's actually not error and result, but rather just result. And now I bet we're going to get our test to pass. Ooh, nope. Ensure done is called. Multiply dot then result. Let's go debug that for a second. Multiply x and y. I'm going to open a new terminal. I'm going to open the JavaScript debugger terminal. And then I'm going to set a breakpoint right here in my test. Okay. npm test. Now the cool part here is that we're using VS Code to be able to set up our debugging experience. Oh. Where are we? Oh, cd to 1, that's why. npm test. Now we're using VS Code to debug our content in a really elegant way. So we'll hit this breakpoint, and then we can step into our code, and it's going to return that new promise. I suspect that will end up here. So let's set a breakpoint here and continue on. What is our result? Our result is 6. So we don't have an error, and that's where we're blowing up. Let's try this again. Okay, I think we've debugged our test correctly, npm test, and let's see if we've got our result. Nope, not quite yet. We're close though. npm test. We've got our result. Our result is 6. We expect that to be that. So let's call this done function. And that is unexpected. npm test. There we go. Okay, so that was fun to be able to debug our test. Let's hide this for now. And because we created a promise-based test, and because promises and async and await work so well, let's build this test again. And in this case, we're going to say 3 times 4. That should equal 12. Now the cool part is if we return a promise, then it will automatically do what we need to do, and we don't need to call done. Okay, so let's npm test this. And because we're returning that promise chain, then we get that in place. Oh, it looks like I need to update this test definition. There we go. And because async and await and promises work so well together, I know I'm testing a promise-based thing, but I can say async here. And so let's test 4 times 5. 4 times 5 will be 20. And now I can say const result equals await multiply. That's perfect. Now, as part of an async method, it will automatically return a promise to calling code. And so this works exactly the same as if we were to return that promise from our test. We can see that now we have 3 passing multiply tests. And we were able to experience not only testing a promise, but testing returning a promise from a test and testing async and await code too. That's cool. Next, let's test divide. And I happen to know that divide is a synchronous test. So I'll just clone add here. Hide add to divide. And we will divide 2 and let's divide 2 and 4. So I'll start with 4 and I'll divide by 2. Actually, we'll say 4 over 2. And I expect this to be 2. That's perfect. Now there is another test for divide. Let's divide 4 divided by 0. Now I expect 4 divided by 0 to throw an exception. So we can say, in our act, we can say try, and then catch error. And now I'm going to say const result equals undefined. Okay, now instead of getting the divide result here, we're going to get the result equals error dot message. Now I can expect my message to be divide by 0 error. Or if we're using modern Node, we can expect this to be a code like 1, 2, 3, 4, 5. So let's grab that code and let's run our test. npm test. And now I've got my thing. Ooh, one of our divides worked, 4 divided by 2, but 4 divided by 0 did not. Expected undefined to equal this code. What's going on here? Let's pop open our divide code. It looks like somebody helped us and automatically returned 0. Now that's not quite what we want. Instead, we want const error equals new error. Can't divide by 0. And let's set error.code equal to 1, 2, 3, 4, 5. And let's throw error. That's what we really want to do when we divide by 0. So now let's run that test, and we can see that we've been able to successfully validate this. Assignment to a constant variable. You are correct. I should not set this as a constant. Rather, this is a let. And so now when I'm running this code, I can see that I've got this. Now it's possible that we could add an attribute or expect.throws, but it's really easy in the middle of our test if we have kind of an overly broad catching mechanism to actually throw an exception in our arrange or in our assert and have it caught by our exception catcher, which is why I really like this try catch syntax here. It makes that really clear that I expect this test to throw an exception and that I'm catching that exception to validate the results. So that was cool. We were able to test synchronous code. We're able to test code with callbacks. We're able to test code with promises, code with async and await. We're able to use our tests to be able to validate that our functions worked correctly in all of our mechanisms, and we were able to use our tests to validate that there was some bugs in our code. That was cool. We could use it to discover our code or to validate our code. These tests worked out really well. And now in the middle of my build, I can just say npm run test, and those tests will kick off automatically. Now we ran npm test a lot, but we could also create a watch mechanism. If we ran mocha in watch mode, so npx mocha -- watch, then now it runs mocha continually. Oh, that's not the correct command. It will run mocha continually, and whenever we have new tests, then it will automatically rebuild them. Oh, it is -- watch. I think I've got an error there. So now we've got our code running in Node, and this is great, but what if we are trying to run our code inside of our browser? Let's switch over to 2 and take a look at the content here. We have all of our divide. Actually, I think I need to delete some content here. Let's delete this and this and this and this. Reset that demo there. Now we've got our add and divide and multiply and subtract content, but we want to be able to run it inside of a browser. Okay, so let's do this. Let's say npx mocha init. Now the cool thing about mocha init is it will create some content for us. Oh, I need to give it a directory. npx mocha init dot. It'll create some content here. So it created this index.js. It added mocha into our root directory and also created this test spec. So if we were to pop this open in a browser, we can take a look at running our tests inside of a browser. Now, in this case, there aren't any tests in the test.spec. So let's come here in our test spec and delete it. Now, we can get our tests from the Node side. So let's just go grab all of these tests and copy them here into our browser folder. Now we will need to add references into our index.html for each of our tests. So let's add add.js, and we will need subtract.js and multiply.js and divide.js. And we will also need the test versions of those: test add, test subtract, test multiply, and test divide. We are going to grab as well chai so that we have that content. So let's come in here to node modules, chai, and grab chai.js. Now, mocha.run will kick off all of our tests, which is excellent. But since we don't have a node build mechanism, then we can't import these things. But we still have chai as a global variable. Let's move it inside of our describe block so that we don't overwrite a constant variable. But as long as we get that content into place, then we've got the same tests and they're running the same content. We just need to set them in place here in our browser. So let's fix up this last test and set the expect there in place. And now if we refresh this page, we can see that it will run all of our tests. Ooh, it looks like we have a failure right here. Should divide by 0. Also looks like we may not have added multiply tests in there correctly. Let me go validate that I've got that. Oh, I guess I did. It's erroring here on should divide by 0. I can jump into that test and I can see the test content there, but I actually want to start up just that test. So now we're logged into just that test, and I'm going to open up the Chrome Developer Tools, and let's switch over to the Sources tab, and let's take a look at that test divide. Now, test divide 4 by 0, I'm going to set a breakpoint right here. Let's refresh our test, and let's take a look at how this works. So I'm going to go into the divide function. Ooh, we hit that return 0 thing again. So now our exception was not thrown, and that's exactly the problem that we're hitting. I'm really glad that we can debug this inside of Chrome. Let's come back into our code and go fix that divide bug. Here's divide, and let's go grab that error logic out of our other divide. Here's our divide. Let's add this new fix in place, and let's refresh this test. This test passes. Very nice. So let's come back to our main page, and we've got all of our tests. Network, test multiply. Did I spell multiply incorrectly? Let's come here and rename this. Grab that file name. I will come back here into index.html. I did. I transposed those digits. That's hilarious. Okay, so now we've got all of our tests. Now, what if we want to test some asynchronous content? I'm going to pull in jQuery. Script source equals jQuery. And I'm also going to pull in this library, script source equals Ajax lib. And let's write some tests for this Ajax lib. Now this Ajax lib uses jQuery, and we've got a whole lot of things going on. So let's create this new file, test Ajax lib.js, and see how we would test this library. Now, let's pull this down here. Describe Ajax lib get all records, and that will create a new scope. We'll go grab our expect and set that in place. And now it should pass results on success. Let's test that condition. Now, what I want to do here is I want to call my library. So let's do that. Arrange, act, assert. I want to call my library. I want to say get all records. I'm going to pass in an ID, and I'm going to get back a function that returns an error and data. Okay, so assert will be in here, and let's do the done mechanism. In fact, I typically also use done here all the time, just so that it's obvious if I've left that off. Okay, so we'll need a const ID. Let's set this to 1, and we'll need some data. So we want expect data to equal expected, and expect error to equal null. We're testing this success path. Okay, so we need const expected equals, there's some data here, some data. Now, how do we mock out this $Ajax call? Because we don't want to actually go get that content. Okay. Now here in our test, we can do some before each. Before each. Now this runs before each test. We also have a before all that could run before all the tests. And so let's say const real Ajax equals $.Ajax. And now before each, I'm going to set $.Ajax equal to a new function. Now in this case, I could do it in a before each, but I probably want to set it to set it to values that I have here, for example, my expected. So I'll do this in my arrange instead. So I'm going to set $.ajax equal to a function. It's going to take in this config object. And I wanted to call the success method. So let's call success, and we'll pass in some data. We've got an expected data here right there. So now we've mocked out this Ajax function and set it equal to our value, config.success. But we do want to be a good net citizen. So let's say after each, let's go put jQuery back. So $.ajax equals real Ajax. This will capture it right at the beginning, and we'll put it back after our test. Okay, so we'll start off our test, set up our fake jQuery. Then we'll call getAllRecords, which will come here into our library. It will execute this. It'll call $.ajax, which will call our fake function. In our fake function, we'll call config.success. Here's our success parameter, which will pass back the data. We'll get our callback with that data. Here's our callback with that data, and we'll be able to assert that our test works as expected. Now we do need to set our done here to validate that we've finished correctly. And now let's run our test. I need to add it to index.html. Script source equals test ajax lib. And now we can validate that we've got this Ajax content going into place. Now the cool part here is we were able to mock out the Ajax library, or mock out the dependency, the jQuery library, so that we could validate our function. Now in this case, we're testing the happy path, but we could create a similar test to catch error details and be able to harvest this in our error callback. That's really cool. We were able to use our tests and create these fakes, these mocks, these stubs to be able to avoid calling into external resources. Now we could definitely use a library like Sign-On to pull in pull in fakes here, but in this case, monkey patching Ajax worked out really well. Okay, so now we've got our tests running in the browser. Now how do we get this into our DevOps pipeline? Well, hey, DevOps person, can you launch a browser and validate that it says passes over here? And if it doesn't, can you harvest the results? For that, let's run our unit tests inside Karma. Now, Karma is a really excellent tool for being able to run unit tests in a browser. Now, these aren't end-to-end tests. This isn't using Cypress or Phantom to be able to do user interactions in a browser. These are unit tests in a browser. So we've got an empty folder here with just the libraries that we need, and we have installed Karma previously. Now let's say npx karma init. And that's where I get confused, because with mocha init you need the dot. With Karma you do not. Okay, so what is our testing framework? I'm going to use Mocha in this case. Do we want required.js? No, we don't. What browsers do we want? Chrome, Firefox, and we could pick from other browsers as well. Where are our tests? Star.js is all of our tests. Do we want to exclude folders? Now we could choose to exclude things like node modules, but in this case, that's excluded automatically. Do we want to keep watching the content and rerun our tests? Yes, we do. And that generated this karma config. So let's come in here and take a look at the karma config. Now this identifies all of the details associated with our tests, basically all the answers to those questions. Now we do want to include chai in this setup as well. But then let's go copy all of our test files that we built right here and just paste them into here, into Karma. Now the cool part about that is it's going to pick up all of the files. In this case, it picked up both our library files and all of our test files. But if we wanted to, we might give it an array so that it could get them in the correct order and document the content that way. Now, we've set it up to auto watch and to run in these two browsers and not set it to a single run. So let's do that. Let's say npm test. Oh, we did one more thing. Here in package.json, I just told it to run karma start, and that way it can do it. npm test. Now the cool part is it's running both Chrome headless and Firefox headless, and kicking off those tests in kicking off all of the tests in all the browsers. Now we could definitely run in head mode, and at that point it would pop up a browser, but it pops up a browser on top, and so if you close it, it will relaunch the browser. That's a little bit less effective. Now it looks like we have a failing test. We get this divide by zero error. I bet that our divide library has that same bug. Yep, there's that bug. Let's go find the fix to that library. Glad we had these karma tests that can help us find problems in our libraries. Now, at this point, we can run our unit tests and run them in both browsers simultaneously. So it launches the browsers, it connects to both Chrome and Firefox, and we get all of our tests passing. That's perfect. 9 of our 9 tests passed in both browsers. Now this was perfect. We were able to run our tests inside of Node. We were able to run them inside of a browser. We were able to run them inside of a DevOps pipeline. Now, if we have Node running server content, that works out really well. If we use a single page application framework, a SPA framework like Angular, React, or Vue, then maybe we're running Node and running our tests inside Node, not in a real browser. But as we get closer to browsers and we want to validate that our content runs in each browser, Karma can be a great mechanism for being able to launch those tests inside a browser and be able to harvest their results. Now the magic question is, so should I use that Mocha developer page? Now it's possible to run Karma in a browser, click on the debug button, and kind of wander through, but I find the debugging experience inside that Mocha test page to be really ideal. So I use both Karma and Mocha. Mocha for debugging and Karma in my DevOps pipeline. Now that's been really effective. We were able to take a look at testing synchronous, asynchronous with callbacks, asynchronous with promises, and async and await code. We used our tests to be able to validate our libraries, to be able to find edge cases, to be able to discover bugs within our libraries. And if any of our code changes, we can run these tests again to validate that our code still works. This has been really fun getting to show you JavaScript tests in Node, the browser, and CI. Grab this code from GitHub by clicking on the link at robrich.org/presentations. I'm going to join you in that spot where the conference is designated for Q&A, or you can hit me up on Twitter at rob_rich. Thanks for joining us.
Welcome back. And now there is some time for questions and answers. I wanted to ask you, I have a experience with a different framework. Do you have an opinion on Jasmine or Jest?
Yes, both Jasmine and Jest are really effective testing tools. In this demo, we used Mocha, but I've done a whole lot with Jest in my modern development efforts, and it works out really well. And depending on the SPA framework you use or the server framework, it may come bundled with Mocha, Jest, or Jasmine. And Yeah, no need to rip it out to put in the other one. In the case of chai, in the case of mocha, it doesn't come with an assertion library, so that's why we pulled in chai, and we use the expect syntax in chai. With both Jasmine and Jest, they have assertion syntaxes built in, and when we said .to .equal, the only difference between mocha and chai is instead of .to .equal, it's .to equal with a capital E. That's it. So if you're familiar with one, moving over to another is really easy. Jest has some interesting things that work really well with SPA frameworks like snapshot testing. And so if snapshot testing is something you really enjoy, you may want to take a look at Jest.
I'm not really sure. So do you think snapshot testing is useful? I found that most of the time, snapshot testing just means that people will just update the snapshots without looking at the difference.
That's been my experience as well, and why I try to shy away from snapshot testing. Snapshot testing, it will just grab a snapshot of all the things that it rendered and just kind of stick that in its cache. And if ever the results differ from that snapshot, then we know that our test has changed. Now, the hard part here is we kind of treat that snapshot like a big black box. And so we're not actually validating that it is what we expect. We're validating that it's the same as it was last time. So if ever we change our code, it's not uncommon for us to just update our snapshot and call it good. At that point, what value is this test? That's why I tend to shy away from snapshot testing and instead look into the resulting HTML. Maybe we use it to serialize the HTML into a JSON object and then query into that JSON object for the data that we care about. Now, there are some places where it's like, yeah, that HTML was just too weird. And so trying to get at the particulars in there, use snapshot testing sparingly. Usually when I have that need to be able to get at a big wad of HTML and I can't really parse it correctly in my assertion, then I tend to flip over to Cypress testing where it can do some of that for me.
Okay. Sorry, I'm reading chat in the meantime, trying to read chat, but no one is seems to have any questions. Okay.
One of the questions I often get here is, so I'm using Angular or React or Vue or Svelte or Node on the server. Can I still use these techniques? Yeah, definitely. We used standard libraries. We use standard JavaScript mechanisms. And so whatever framework you're using, you can kick off into that framework and accomplish the test that you need to. Sometimes you might use a library like testutils. Testutils allows you to mount your component and either mock out child components or render them. And that can be a great way to be able to validate a specific component in the middle of a test. If you're not using a SPA framework, if you're just using straight JavaScript, then exactly what we did here is exactly what you'll do in your tests too.
Using your example, like your talk, how hard would it be to progress to end-to-end tests or integration tests from your examples?
That's a great question. And we'll probably want multiple suites of tests. We'll want unit tests like we have here. We might want component tests where we validate that it renders correctly. And we'll probably want integration tests, end-to-end tests. We may also want functional tests and other production run tests. The same technique of creating arrange, act, and assert works perfectly for end-to-end tests. We're still in JavaScript. And so all of those mechanisms will work just fine. When I pull in Cypress, I can pull in, Cypress is actually built on top of Mocha and Chai. And so I get the Mocha and Chai assertion experience and the test building experience. I have the same describe block, and in it, I have all of my it and the it methods to be able to validate things. I will be using another library, so I'll need to pull in Cypress to be able to understand how to interact with the page. But after that, everything is pretty much the same. You'll see a lot of carryover in the skills that you've got. Now, once you move to end-to-end tests, you're not going to throw away all of your unit tests. you still want to validate those small units of work correctly. And so you'll have a suite of unit tests, you'll have a suite of component validation tests, and you'll have a suite of end-to-end tests. And in your DevOps pipeline, you'll run all of them. Now, the cool part is the end-to-end tests are probably the slowest out of that suite. And so probably run them in that order. Run your unit test, then your component test, then your end-to-end test. Because if you have a failure in a unit, there's no need to spin up the entirety of the Cypress browser experience just to be able to validate that, yep, I have a failure in my unit. Fail fast, get that fixed. And then as we progress through more aggressive rounds of testing, then we can validate additional content.
Right. This is the classical test pyramid, right?
Exactly.
So fail fast, fail early, and you don't need as many expensive tests, hopefully, if you have a good foundation of the less expensive tests.
Exactly.
Right. Okay. And I had something else, but I forgot. Sorry.
One of the questions I often get here is testing worth it? I'm paid to deliver production features. Why am I spending my time writing unit tests? I completely agree. Your goal is to deliver quality code. But how do you get there? Do you spend a lot of time debugging? Is debugging fun? Spending all that time spinning up the scenario, clicking through all the pages, and then clicking F10 and F10, F11? The cool part about writing unit tests is you can debug your code by writing more code. And this code that you write, the unit test, can be really fun. As you write the code, you can take a look at it from the user's perspective, not from the code writer's perspective, and see how you would consume that. That kind of sets you in a nice mindset to be able to build good APIs into your code, and that can be really helpful as well. But as you set up a unit test to validate that your function works correctly, and then you see that code either fail or pass, that gives you additional information. And you got that information not by pushing F10 a dozen times, but by writing more code. And, well, writing code's fun, so let's do it. In time, you may find that you're actually more productive because you can validate these small units of work correctly. And then once you start bundling them together into larger components and higher level components, then you don't have to worry about, hey, did that component way down there in the tree still work? Of course it works. I have unit tests that validate that it functions correctly. You can actually code faster with unit tests.
Oftentimes I hear that it's not really about the developer asking, why should I write tests? Because if you write code, then sooner or later you will realize that it's a pain to find a small mistake that could have easily been verified early. It's harder to find once it's up the pipeline. So if you build a small block into a bigger block and into an even bigger block, and then it fails, then it's harder to find that it was the really small block that failed than if you were to verify the behavior early. But oftentimes I hear that it's not really the developer who is against tests. It's more like delivery managers. So people are asking, why are you so slow? Why do you need this? Why do you need that? So what would you say if someone came up to you and told you the deadline is tomorrow? We can't waste time to write tests. Right? Okay, so maybe not tomorrow, because then you really have to get it together. But so soon, like if someone is trying to push you to stop writing tests, how do you deal with that?
That's a good question. And from a business perspective, yeah, we're not shipping this code. Why are we writing this code? Unit tests are about risk mitigation. And so what's the likelihood that this code is going to fail in production? And what is the cost of that failure if that occurs? Well, we can eliminate the need for that failure. We can eliminate the possibility of that failure by writing tests that validate that this scenario works correctly. So if nothing else, we're removing that risk. Now, we definitely do need to ship tomorrow. So we need to weigh the value of mitigating that risk versus delivering early and accepting that risk. But as a good rule of thumb, whenever there's a production outage, Let's first get production back online, but then I'll back out that code and I'll write a failing test. Now, maybe that's a failing test in Cypress where I'm doing an end-to-end type of experience, or maybe that's a failing unit test that validates that this function is behaving incorrectly. Then I'll go fix that function. Now I have a test that will validate that this failure will never happen in production again. If you do that a dozen times, your production system will be a lot more reliable. So take on that challenge. Write a dozen unit tests, get them to run in your DevOps pipeline just by running npm test inside your build script, and see if that risk mitigation practice helped. Were you able to deliver more confidently? Were you able to realize less production downtime? Were you able to mitigate risk better or resolve issues easier? Ultimately, now you can go back to your manager and say, you know what? Here's the data that we had before we started unit testing. Here's the data that we have after unit testing. And you can see that our system is 28% more reliable. We've had 7 fewer production outages since we began testing. Now, is that of value to you? And at the end of the day, they may come back and say, no, we really want to push faster no matter what the quality of the code is. And that is an acceptable answer. Or they may say, wow, we're making a whole lot more progress in making much more durable production code. Yes, we do need to invest in testing. And testing can make you more productive, test faster, because you can validate those units and you don't have to go through and debug the big thing to figure out which unit failed. So in time, I suspect that you'll actually be more productive with unit tests than without them. Now, that is an argument. So if they really start, I've been on one project where they just went through and deleted all my tests periodically. You can change your company or you can change your company. And ultimately that project didn't work out and I switched to a different one.
All right, thank you. What do you think about test-driven development? So where you write your tests first and have them all fail? No, sorry. I think
test-driven development is really interesting.
First. Sorry, go ahead.
In some languages, you kind of can't do that because the compile doesn't work because the code that you're testing doesn't exist yet. So you might need to stub out things just a little bit to get the test-driven development tests to run and then fail. Test-driven development is really great at helping you discover an API or a user experience that you may not have thought of yet. It's great because you can describe the feature that you want, the consumer's way of interacting with that feature, and then you can build the code to make it happen that way. So if it's a particularly weird algorithm or a particularly difficult way of interacting, then test-driven development can be really powerful in helping you to build out just the bare minimum of features that you need to accomplish that task. Now, on the other hand, if it's a very well-known problem and you understand how to solve it really easily, then you may have more success just building out that feature and then building the tests around it to validate it. Because you know where you're going, you don't need to discover it. I tend to use a mix of test first and test later to be able to accomplish the needs that I want. When I have a problem that I don't understand, I'll use test-driven development. And when I have a problem that I do understand, I'll write the tests along with the code. What I love about test-driven development is it sets you in the mindset of the consumer of your code. And that's a really unique and powerful position because, well, if you're building something that is elegant for you as an implementer, but is really awkward to use, or your abstraction is really leaky and they need to understand how your internals work to use it, that's something that your test-driven development tests will probably expose. You'll start by consuming your code and you'll go, you know, this is a really ugly way to interact with my code. I'm going to not do it this way. And it may help you create more robust, more elegant designs for your code. That can be great. In time, you get into that mindset of thinking like the consumers of your code, and you may not need the tests to help you get into that mindset again. And so if test-driven development helps you get to that point where you can be much more compassionate about the users consuming your code, then that's perfect. Use test-driven development to gain that compassion and to build really elegant experiences for the consumers of your code.